the most powerful, underutilized tool in your kitchen is resistant starch. Normally, starch in white bread or fresh rice is rapidly converted into glucose in the small intestine, causing a sharp spike. However, resistant starch resists this process, traveling to the large intestine where it is fermented by gut bacteria into butyrate, a fatty acid that actively improves insulin sensitivity and reduces inflammation. How to create it? Cook, cool, and reheat. When you cook rice, pasta, or potatoes, and then cool them to refrigerator temperature around 4 degrees Celsius for 24 hours, the starch molecules realign into tight structures called retrogradation. The benefit: this process turns starch into something that behaves more like fiber. Even when reheated, much of this resistant starch remains, resulting in a measurably lower blood sugar spike compared to freshly cooked versions. Common foods. This principle also applies to bread that has been frozen and then toasted, and naturally occurs in legumes and slightly underripe. Bananas. Eating starch in isolation creates the sharpest glucose peaks. You can cut the blood sugar impact of a meal in half, up to 50%, simply by including protein, healthy fats, and acids. The power of pairing. Protein and fat slow down gastric emptying, meaning the stomach releases glucose into the bloodstream much more gradually. This is why rice and beans are metabolically superior to plain rice. The acid trick: adding vinegar, lemon, or lime juice to a starchy meal reduces the rate at which enzymes break down starch. The order of operations sequencing. This is one of the most effective tools available. If you eat your vegetables and protein first and save the starch for the end of the meal, you can reduce the glucose curve by 40% and the insulin response by 31%. The fiber and protein act as a buffer, ensuring the sugar enters the bloodstream as a slow trickle rather than a surge. One of the most impressive clinical findings is that a simple 10-minute walk taken within 30 minutes of finishing a meal significantly reduces blood glucose. The secret lies in the soleus muscle in your calf. This muscle is composed of slow-twitch fibers that are highly efficient at sustained activity without fatigue. When you move after eating, your muscles take up glucose through an insulin-independent pathway. Essentially, your muscles act as a glucose sponge, soaking up excess sugar regardless of your level of insulin resistance. The problem often isn't the carbohydrate itself, but how modern food processing has changed its physical structure. Fine flour kindling. When grain is milled into fine white flour found in white bread, crackers, and instant oats, the surface area is so vast that enzymes break it down instantly. It's like throwing sawdust on a fire. It burns intensely and quickly. Intact grains, logs, foods like steel-cut oats, barley, or legumes have intact cell walls. Your enzymes must work through a fibrous matrix, releasing energy slowly and steadily like a sturdy log on a fire. Fibers roll. Soluble fiber creates a gel-like matrix in the gut that physically slows glucose diffusion. It is the most metabolically valuable component of your food and should be the last thing you cut from your diet. Your body's ability to process sugar is not constant. It follows a circadian rhythm where insulin sensitivity is highest in the morning and lowest in the evening. As you approach sleep, your body produces melatonin, which signals the pancreas to suppress insulin secretion. Therefore, a starchy meal eaten late at night, when your tissues are less responsive and insulin is being suppressed, causes glucose to stay elevated far longer. To mitigate this, aim to eat your last meal at least 3 hours before bedtime to align with your body's natural metabolic clock. Managing blood sugar does not require you to abandon the foods you love. By adopting these 6 strategies: cooling your starches, pairing with protein, sequencing your bites, moving after meals, choosing whole structures, and timing your dinner, you'll provide your body with the right inputs to manage glucose effectively. Your body is capable of far better control when you understand the biology well enough to work with it rather than against it.